Hello, in this video we're going to see operations on set. So a new set can be formed in a variety of ways and can be described using both set builder notation and Venn diagram. So for example here, let's say we have set A and B. So the union between the two sets is this blue thing, which is A or B, any element in A or B. So we write it as union, U in between. And then with the set builder, you could say A union B is all x's such that x belongs to A or x belongs to B. So the intersection of set A and B, and we write it like upside down U, is all the elements in A and B at the same time. So as we could see here, if we have the following example, such as A 1, 3, 5, 7, 9 and B 3, 7, 9, 10, 15. So A union B will be everything in A and B without repetition, and A intersect B is just 3, 7, 9. So this joint set are the set that they have nothing in common. So like let's see here, you have set A and set B. So the A intersect B is an empty set, and therefore we call A and B disjoint set. In other words, there are no elements in A that are also in B. So for the set A to be an element of the power set, the complement of A, which is either you write it this squiggly line A or A with the prime. So this is the set that are not in A, everything else but A. For example, if U is 0, 1, 2, 3, 4, 5, 6. And A is 1, 2, 3. So here 1, 2, 3, and here will be 0, 4, 5, 6. So not A is basically 0, 4, 5, and 6. Anything but A, but within whatever universal set you have. The difference of A but not B. So for example, if A is 1, 2, the common is 3, and B has 4, and maybe 5 is here. So basically U in this case is 1, 2, 3, 4, and 5. So for example, where would be A but not B? That means choose any element in A but do not include what's in B. 3 is in B, so even A has 1, 2, 3. I'm not going to include 3 in this case, because we say in A but not B. And in another word, this is, we call it the set difference, is one of the properties. A but not B, you could write it as A intersect not B. And remember, B but not A is different than A but not B. So B but not A will be equal to just 4. Let's see this example. So let's see, we have A, B, and C, and the subset S, or as I called earlier U, is 1, 2, 3, up to 10. So let's draw a Venn diagram here. So as we see here, A has 1, 2, 3, 5, 10. B has 2, 4, 7, 8, 9. So what's common between A and B is just 2. What's common between B and C is 8, and what's common between A and C is 5 and 10. So A has 1 and 3, B has 2 and 4, B has 7 and 4, and 9. So as we see, this number 6 here is not in any of A, B, C, D, so must be here. And this is the set S. Now we could easily answer these questions. What is the union of A or B? That means take everything in A or B right here. So what would be A but not C? Meaning everything in A but do not take C, which is 1, 2, 3. So what would be A or C? So A or C is this in here. So A or C is basically 1, 2, 3, 5, 10, and 8. But do not take anything that has B. Well, for me, B is 8. So we're not A or C, and not B, will be everything but not in B, which is 1, 3, 5, 6, and 10. So what is basically the intersection between A or C and not B? As we see, we have 5, 10, and 1, 3. So the answer is 1, 3, 5, and 10. So what would be the intersection of A, B, and C, which is this area right here? The intersection for all of them, there is nothing. It's an empty set right here. It's an empty set. What would be the union of A and B, which we have here in red, will intersect with not C. So not C will be all of this here, including 6. So this is not C. 1, 2, 3, 6, 7, 4, and 9. Intersect this with the union of A and B. That means I need only these 6 members here. 1, 2, 3, 4, 7, and 9. So as we see, sometimes drawing a Venn diagram can help picture things better. Let's see another concept here, where we call Cartesian product. What is a Cartesian product? If A and B are a subset of S, then the Cartesian product, which is cross product of A and B, denoted by A cross or multiply X by A multiply B, is denoted by all pairs XY such that X belongs to A and Y belongs to B. Always A first, then B, because A, B. And remember that cross product AB is different than BA. So now we answer this question. No, it's not. So what we say, because XY is different than YX, especially if X different than Y. One element of A, one element of B. So let's find out what is the cross product of AB. So A is ABC and B is 1, 2, 3. So remember, I need the curly brackets and then the element inside they're gonna be an ordered pair. So what we have, we start with A. We could say A1, A2, A3, and again B1, B2, B3, and the last is C1, C2, and C3. So this is AB. So if I was asked BA, it will be flipped 1A, 2A, 3A, 1B, 2B, 3B, and 1C, 2C, 3C. So that would be B cross A, but which is different than A cross product B. So from here we could say that the cross product of a set with itself is a kind of square, and order n tuple in a set of n element that is defined by the order in which the element appears. An example would be the coordinates of a point on the graph are order pair, where the first value must be the x coordinate and the second value is the y coordinate. And if you have 3 dimensions, then you're gonna have 3 elements within each point, which will be x, y, and z. So if you have n dimensions, so you have a to the power of n represent the set of all n tuple x1 to xn of element A. So let's see more examples here. So again, I have set A, B, and C, and the universal set S as P, Q, R, S, T, U, V, and W. Let's draw a Venn diagram. So as you see, A has P, Q, R, S, B has R, T, V, and C has P, S, T, U, and the S is P, Q, R, S, T, U, V, and W. So now we could answer the questions. What would be B, but nothing from C, which is just R and V. Now the question B is, where is A union B? Negate that, the complement of A union B. So as we know, A union B is right here, but we don't want anything with the A union B. So what does it mean? Everything outside will be U and W. Now what would be the cross product of A, B? That means P, R, PT, PV, and so on. So here is the cross product. So again, A cross product B is PR, PT, PV, QR, QT, QV, RS, RT, RV, and SR, ST, SV. So as we see, the cross product, the element, the cardinality of A cross B is 4 times 3, because there are 4 elements in A and 3 elements in B. So 4 times 3 will be 12, so that's why we see 12 in here. So the last question here, D, where we need is A union B intersect with not C. So A union B is here in red and intersect with not C. So not C, anything but C. So outside of C we have this. So the intersection of A union B, which is right. So what we have there is QRV.